Hi guys and welcome back. In this video we're going to be testing our first function, and it is this divide function here. Really simple function. All it does is it takes two parameters, dividend and divisor, and divides one by the other. We're going to be doing a little bit more in this function later on, but for now it's just this. I've also added the typing module here to say that the dividend and the divisor are both ints or floats. Let's go over to our test functions file to begin writing our tests. It is important that your file is called test underscore and then the name, because that's what unit test is going to look at in its default configuration. You can change that later on, but we're not going to look at how in this course. The first thing to do here is to import the test case class from unit test, and also of course our divide function. Then we're going to create a class test functions, for example, and is going to inherit from test case. Inside here, we can write our first function. Functions should also start with test underscore. For example, test divide result. This test is just going to check that the divide function returns what we would expect a divide function to return with two normal values. So we'll say that the dividend is going to be 15, the divisor is going to be 3, and the expected result is going to be 5.0. These are just variables. They don't have any specific meaning in our tests, even though they have the same names as the function parameters. It's totally irrelevant. You can name these whatever you want. What is important though is that you do self.assert equal divide of the dividend and the divisor, and then the expected result. So what we're doing here is we're passing to this assert equal method two values, divide, or the result of executing the divide function, and our expected result. And it's going to check that they are the same, so that dividing 15 by 3 is equal to 5.0. We have written our first test. Now, if you're using the default configuration, i.e. your file is called test underscore and your tests are called test underscore and then the name, you can right-click test functions using PyCharm and run the tests. If you are using the terminal, we will have instructions on how to run these tests on the terminal in a little info box. So let's press run, and then you see that you get ran one test in 0.002 seconds, and it is okay, no tests failed. Whenever you're writing a test, it's very important that once you've written the test that you're happy with, you play around with it to make sure that it is actually working. So now I'm going to change the expected result to 4.0, and when I press play, this test should fail. And it does, which is good. And it says here the expected result is 5.0. At this point, let me say that in some cases, when you make a division in any programming language, the result may not be exact. So it could be 5.000000001, just because of how the computers do division. And we'll have some links in the resources section of this lecture to explain why that happens. But if the division was not exact, that is okay if you use a slightly different method. So instead of self.assert equal, whenever you're handling division, I always recommend you do self.assert almost equal. And then the last argument after divide and expected result is a delta, which is what the allowed difference between these two values is. That is just in case there is a small inconsistency in the division there, that this will still work. So now that we've done this, let's press play again, and the tests pass. By the way, down here on the bottom left, there is a small icon that says toggle auto test. This is something you can click on PyCharm, and whenever you make a code change, the tests will run automatically. I usually leave it on when I'm writing tests and I have my code, like in an application. For now, we're going to leave it off, but it is there if you want it. It can be helpful. Let's begin writing our second test, which is for a different equivalence class. We're going to talk later on what equivalence classes and boundaries are when you're talking about testing, but essentially you want to start thinking about what different types of values are that your functions can take. For example, this function in this test we've tried with two positive non-zero numbers. I would call this one equivalence class. These two numbers are similar. You could, instead of 15, type 30. Instead of 3, you could type 10. But you would expect the function to work in the same way with 15 or 30 or 300. However, it may work differently if you put in a negative number. And that is what I would call a different equivalence class, a different type of input. So we will write a test for negative division. And here we'll say that the dividend is 15, the divisor is -3, and the expected result is -5.0. And then we will do exactly the same as before. We will just test that. Calling the divide function with these two arguments will result in this, or it will almost result in that. Pressing play gives us an okay result once again. Finally, we can try a third equivalence class, which is for a 0 number. So we will say test divide dividend is 0. We will set the dividend to 0 and the divisor to 5. And then the expected result should be 0. Whenever you divide 0 by anything, it should be 0. And now we're going to say self-assert equal, because I don't expect the output to be 0 point something. So I don't want to do self-assert almost equal. I want to do self-assert equal. Pressing play again, and there we have our 3 tests. You can see that writing tests can be very straightforward when your code is very straightforward. Here we've got a simple function that doesn't do a lot, and we still had to write 3 tests for it, but they are all very simple tests. And in a simple test, which is a test that I like most, you have your inputs and your outputs defined in the test, and then you have a single check or a single assert at the end. There is a benefit to doing tests in this way, which is that it's really clear what the function does. The function should be able to divide, it should be able to handle negative results, and it should be able to handle a dividend of 0 without giving you an error. We will be adding more tests and also other functions in the coming videos, but try always to keep functions or classes, if you're doing that, simple, and your tests simple and straightforward as well. Let's move on to the next video. I'll see you there.